we are in the world. But welcome to the Ross Agriculture Community Meeting. Ross Agriculture is a focused initiative of the Robot Operating System, and together we are creating an ecosystem to empower farmers with robotic tools. Thank you for being here tonight. We've got a couple of guests. Matthew, would you like to introduce yourself and maybe talk about some of the work you're interested in?
Sorry, guys, I'm using a cell phone tonight. My name's Matthew, and I'm just interested all around in pretty much every bit of any way that ROS can be used for agricultural purposes. Currently, I'm working on a robot lawnmower, and I think after I get that, on to doing simple agricultural stuff, maybe a combine or a planter or something like that. That's about it.
You're using the lawn tractor as a learning platform?
Right now, I'm actually using a wheelchair platform.
Okay.
And I'm using that, and I'm trying to use a real mower, and I've got a web page that I've got everything put on there where I've been doing it little by little as I collect parts from here and there, and just build on and build on.
That's the way it works. That's cool. Are you a ROS developer, or how did you get involved with ROS?
Well, I got tired of mowing my yard, so yeah. So just because of that, I got involved with ROS. So.
Some healthy motivation there. I didn't catch that last part.
I'm going to mute my microphone because I'm playing with some toys.
Okay. Nice seeing you. Elsa, nice seeing you twice in one day.
Yeah, hello. Yes, I'm Elsa Figueiredo, and normally I will be in Denmark, so now it's 3 o'clock in the morning, so going to be difficult to join the meeting. Today I'm in Minneapolis entire week. So I'm working at Danfoss in Aalborg. We have a team, autonomous team that development autonomous solutions for agriculture and other machines, power solution machines like this. So I'm quite new in ROS, but I have a quite experience in the program C and MATLAB and this kind of things. So, but I've been working with ROS, specifically with ROS, maybe 1 year. So since I joined the team. So.
Excellent.
I don't know if I answer all the questions, but yeah.
Great. Thanks for being here tonight. That's fascinating. Denmark, is there a lot of agriculture robots going on over there?
Yes, we have a big companies also, robots companies that Universal Robots, that is, yeah, it's a big, huge company. And we try to make some kind of machines to do this stuff. So.
Excellent. We're going to need it. The word on the street is we're going to need a lot of robots to grow food.
Yes, true.
So tonight we kind of have an open meeting. Sohin has a new robot project. I don't know if you want to show that. And I've got a little demo of the TEB planner. And if anybody else has any tech demos or anything they want to show, it's open.
I'm gonna take some time to find out the picture I took. It's hidden somewhere, and I'm not gonna be able to find it real quick. So if anyone wants to jump in, I'm totally fine with it.
So I just posted a link that I found today. Let's see, my mic on. Can you hear me?
Yep.
I just found this link, and it's something that we wrote from scratch to make this work. It's for when you're running Gazebo and you want to define an Ackerman vehicle. You have to have you go into your URDF file and you put down joints for your two wheels that you want to turn in the front, and then you have to control those externally. So you have to write an external program to do that. And it turns out I just stumbled on this link today, and it's a package that apparently does that for you. I haven't looked at it real hard, but I think it basically subscribes to your command velocity and then turns the wheels by sending topics to Gazebo to tell it to turn the wheels for you. So I posted that. You can take a look at that. And if you don't have a package to do it for you, you have to write a node that will subscribe to your, say if you're using command velocity, but you're using a steer angle as opposed to rotational velocity, you take the angle and then you do all the calculations, and then you tell it to set the left angle at this and set the right angle at this in order to get the thing to drive around. So that might come in handy for if anybody's trying to figure out how this stuff works or just wants to go ahead and use this. And originally, I think I found, when we first started off, we said, okay, we need to create an Ackerman vehicle for Gazebo, and I did a lot of searching, and it was the little radio-controlled car that it kept coming up again and again, that somebody had modeled that in Gazebo. And basically, we started with that, and I said, okay, this is how you need to do it. Then the smart people took over and made it actually work. So, but that's where I first ran into the stuff, is how it works. So.
Yeah, that Traxxas model seems to be the Ackerman model for most of the vehicles in Gazebo. Thanks for finding that. Part of ROS, it seems like, is if you're lucky and you happen to come across a package that will do what you want, if you can find those.
And it's amazing that these things will just pop up out of nowhere. And, you know, this was probably written years ago, and this is the first time I've seen this. Because, you know, years ago, I think at ROSCON 2012, when it was the first ROSCON they had, and that's the one I went to, and the guy said, he had a slide behind him up on the board, and it says, we now have 3,000 packages. And he says, oh, that's way out of date. They had like 6,000 packages at that point, and that was 6 years ago. So they've got, I haven't even looked recently to see how many packages they have, but there's no way you could know what all's out there. So, and even when you search for it, this stuff doesn't normally pop up. So I just stumbled on this looking for something else. I was trying to figure out how to set PID gains, because it turns out that Gazebo 7 does not work under Kinetic correctly. And so I've spent the whole day, actually the last 2 days, trying to figure that out. And I'm getting closer on it. But so this popped up while I was looking for that stuff.
Excellent. That's funny. I know you do a package search. You may spend a week or whatever looking at packages, and then 6 months later, you may come across the exact same thing you were looking for, but didn't find it then. So that model in Gazebo, we don't have an Ackerman model or a little lawn tractor model. I've been using Stage, which is just the 2D simulator. And basically, it's a really low quality or low processing power simulator for ROS. And it'll just give you pretty much exact ODOM back. It's not generating GPS. It will generate like laser scans and some things like that. But you basically just use it as a tool to practice driving around if you don't need to simulate a full 3D model. Maybe I'll just show you a demo. All right, live demo. So I've got a few windows open here, but this is Stage simulator. And if this is just a drawn in little symbol, but that's your car. And then in RViz, you can send it a 2D nav goal, give it the spot and the orientation, and then the planner will drive your vehicle there. And this is just a way to test driving around without having to run the full gazebo simulator. And then you can also use this, I don't know if you've used the RTQ dynamic reconfigure, but if you're working with your robot and you want to test the min turn radius, or if you want to adjust something like that, then you can adjust that through this dynamic reconfigure window and then test your settings. And if you look at the configuration file for the TEB planner, it isn't too bad to switch from an Ackerman. If you just change this one, if you change the turn radius to 0, then that'll be like an omnidirectional robot. And then on your footprint model, if you want to do a car, you just give it a type line instead of a point, and then you tell it the start and the end. And this basically draws a little box. The rectangle box is your footprint. Has anybody used TEB before, or any questions on that planner? So there's multiple planners inside of ROS, and then each planner can do different types of vehicles. So this is the TEB planner, use that for the local planner, and then the FN for the global planner. Is that a lot? It looks simple. You just click around and you can drive your robot.
Yeah, we are using TEB planner on at least one of our tractors. I'm not sure what the other, if that's what we're using on everything or not, but the same thing you're doing there, we can have a full-size vehicle driving around dangerously out in the parking lot or out in the field. So.
Yep. I think one of the interesting concepts with ROS is on that simulator, stage is listening to a command velocity topic. And then it's moving your robot around that simulated environment. But your real robot is also listening to the command velocity topic. So there really is no difference between the software stack, whether you're sending a command velocity to your simulator or sending it to the robot. It's a nice little break there. I don't know what you call that, abstraction layer or something.
Did you modify your command velocity so you're getting steering angle, or are you still using rotational velocity?
Yep. So with TEB, it will do that for you. So I can show you that.
Yeah, as you scrolled past in that, I didn't see it show up, but that's what we did too. We said to set it to angle instead of rotational velocity, so that thing does your conversion for you.
Yeah, right here in the configuration file, command angle instead of rotational velocity. Set that to true. And the planner will change it for you and send out steer angle. So kind of one of the things that we're working on is putting together, so this is really just running the TEB planner. There aren't a lot of other nodes like safety nodes or any other thing going on here. So basically just starting out with the TEB planner itself, just that node, whatever it takes to get that running, and then we can add packages on top of that. I did test out like a waypoint navigation system that Al sent over from Daniel Snyder and their robot. But we're still kind of working on the full software package, and then how do we bundle that up and then be able to get that out to everybody.
I don't have anything to show off at the moment, but Bob invited me up to his farm this weekend. So Bob, the Mahindra guy. So we're going to go up there. We're going to play with robots Saturday. He said he's going to put his actuators back on his tractor because, you know, he made the statement that he has to keep it in stock condition so his family doesn't get upset. So he said he's going to put the actuators back on. I'm going to take my mini tractor up there and show that to him, maybe try driving it around a little bit. So maybe we'll have some reports next week on how all that went.
That's good. If we had to put snowplow on Bob's tractor now and get the tiller off of it.
Yeah.
I have my pictures up.
Yep.
If I can take a few minutes here and see if I can. You guys see it?
Yep.
Okay, yeah. So I had this thing, but never actually got it to work. I didn't get it to work with teleop, but I never tried it with, you know, GPS because we were short on time at that time. And right now, I don't want to take out the bigger robot every time I want to test it. Plus, in the city, we don't have a space where we can actually test our robot like the bigger one. And each time we want to take it out, we need a permission from our school to run it on the school grounds. And I usually try to do stuff on the weekends now. So that's why I felt the need to get this one working. And now I had this car for a long time. I mean, my department did. So I have like 2 batteries in here, both are 7.4 volts. And then I machined these wooden, you know, blocks and then screwed them on top of it. And then, so it gives it enough height. And then I have a Velcro on here. So it's like it snaps on, the NVIDIA snaps on, I'm trying to find the NVIDIA. Oops. Yeah, so that's my NVIDIA TX1. And then I hooked up Kyler's IMU on here. And I haven't connected it on this picture, but I got it working finally with the NVIDIA as well. So that's a plus. And then that's how it looks now. And it sticks pretty well. The Velcro is really nicer one, like one of the nicer Velcro. So it sticks on and it doesn't like, I've tried, you know, pushing it upside, like putting it upside down and trying to get it off and it doesn't get off. So I would assume it would, I mean, that's my sort of test on robustness of those things, but it works, I guess. So, and then the NVIDIA is really cool because it can take from 7 to 19 volts. It doesn't care. So as long as you give it enough power, I mean, yeah, current. So I was able to connect those 7.4 volts volt batteries to the NVIDIA without any hassle. So it's really cheap in terms of power, as if we compare it to the AgBot, the actual bigger one, where we are using lots of power trying to run a full-size computer. So this is so nice. Yeah, and then it's just a different view. I've tried to stuff everything in there. It's a lot, and then I'm also going to use this Xbox controller this time to actually have a nice teleop control rather than etching into it every time and like walking with my laptop on my hand. So yeah, that's the hope. But for now, I'm just working on localization. I'm trying to get the step planner working. Once I have that, I'll do some actual, you know, my friend Arjun, he's working on trying to get the hardware of it working. So I'm sure he'll get it as soon, like way before I get the localization working. But that's all I have, I guess.
What's that red box in front of your robot?
That's a VEX sonar, ultrasonic sensor.
Okay.
We tried to use it the other time, but I just haven't, you know, I haven't hooked it up, but it works with an Arduino. So at first I was just going to use the NVIDIA to power, to send signals to the motors. But then I realized that NVIDIA doesn't have like it doesn't support PWMs. So I'll have to buy a PWM board. So I figured like instead of getting a PWM board, I'm just gonna go with an Arduino and connect it over serial, because all I need to send is like, I just want to relay some messages about like, to control the two. So there's a servo in the front right here, and then a DC motor on here. So I'm using a SparkFun. I don't know if you can see it, but yeah. Oops. No, sorry. Yeah, there's a tiny SparkFun motor controller that I'm using, or we're using to control the motors, and then we're using the Arduino and we're connecting that to the Arduino. Initially, the idea was to use the NVIDIA for this, but then it's almost the same. Like you use a PWM, or I just didn't want to wait for the PWM to arrive and go through all of that. Mm-hmm. So I just wanted to make the robot working.
So on that motor controller, are you controlling the throttle through that? So you're bypassing the ESC, sorry.
I don't think there is any ESC on this one. It's just the motor. Like so if you see here, I'm sorry. I'm trying to figure out how this works. Yeah, those are the two cables I get out of the motor.
Okay.
It's a DC motor. It's not a brushless. I think it's a brushed DC motor. It is a brushed DC motor. I'm sure of it. I'm sorry, I don't think so. I know it's a brushed DC motor. So I just have these hooked up. So I just connect them to the controller, and then I'm sending signals through Arduino, and then I'm using the program that we use for the AgBot, a version of it, to send signals to this machine over ROS serial.
Excellent. You're working on localization. Are you going to put wheel encoders on that guy?
I don't think so. I'm just trying to work with GPS and IMU. That's the case on the actual AgBot. We don't have wheel encoders in that one. So I'm not trying to use wheel encoders. I'm trying to see how it reacts, because I'm pretty sure like both the systems react differently because of the size. The AgBot reacted differently because of the size of the machine. Like the Dev local planner reacted differently when we tested it out at the competition, and I want to see how it reacts like for a smaller machine.
Excellent.
But yeah, that's all I have so far.
Do you have a camera on that?
I plan to have a camera on that. I'm just going to take off the Intel RealSense, but it's at a later stage. I'm going to have so much of graphics processing power on this one that I'm trying to put everything on it. But I think the router will break before I put everything on it. But I'm being optimistic that it will survive, because right now it's really heavy anyway. Like I don't see, because it has 2 batteries on it, and then the NVIDIA and the acrylic sheet and everything. Yeah, it's really special on those suspension things, those plastic,
Shocks are all bottomed out.
Yeah, but I don't know how it's gonna end up, but I don't really care right now. I just want to make it work. So I'm just gonna work on the software part of it and try to have the software working. I've learned like I can come up with hardware like this now. It's just out of experience. I got this thing working like within the weekend of Labor Day, like the Labor Day weekend. So I'm really confident that I can, if this breaks, I'll get a new one and get it sorted. But software is really important, I think, and that's what I want to focus and utilize my time and spend my time on.
Yeah, last week Chris showed us the Turtle rover, and I was looking through the Turtle rover site, and they have they use a 180-degree field of view fisheye camera. It's like $60, But that's pretty neat. I don't know if you've looked at that, but for your image processing, you could almost get a 360-degree camera for like $150.
Oh wow, yeah. We got the Intel DualSense for almost the same price, so I don't know. But that's a depth camera. I want to use the depth camera in the future. I don't know. I have so many aspirations. I don't know. I just don't have the time for it. I want to do so many things, but yeah, we'll see. I don't want to jinx it right now. This is what I'm working on. If I get some time, I'm going to use the DualSense to do some interesting stuff too.
Get localization and then get the tab planner.
Yeah, have it go on the field. Then we can have everyone's, mow blowers and lawn mowers and everything automated first. That's the whole, yeah.
You can work out a deal with the coffee shop on campus to deliver coffee around to different businesses with the robot, or different people, departments.
Yes. That would be indoors navigation. Maybe an outdoors robot would be. I mean, that's what I really am trying to get it working outdoors without a LiDAR and see, because without a LiDAR a robot goes blind. It's an interesting problem to solve.
Yep.
Yeah, that's all I have.
Thanks, Sohin. It looks like fun. Colin, did you make any progress this last week?
Hi, Nate.
Hi.
Very soon, Nate.
Very soon? We have a couple new people here. Colin is a farmer down in Zimbabwe, and he's up at 3 a.m. in the morning and is learning how to build robots. He's got some good projects underway, but it takes a little while to get up to speed with robotics. I don't exactly know how long, but I've been at it about 7 years, and I figure I probably have another 10 to go. I'll feel comfortable.
Yeah, Matt, I don't know if I think I mentioned today for you that my expertise is more software and math. So I work a lot with math. So I have some algorithms that I can see that Matthew work with Low more. And in the past, I developed some algorithms that define one area. They building a zigzag plan automatic for you. So I don't know if you are interested in see that as actually I did in MATLAB, but this can be turned in C, and so this is can turn in the. So maybe I can show the system for you.
Sure.
But I have a kind of a little YouTube film. And maybe we're going to use this in our Davis. Let's see how this is doing. So I don't know if you are interested in see that, because I can see that you talk about hardware. So I don't have no hardware to share. It's more Jeff is our hardware guy. So.
We definitely like software. We've just been stuck in hardware land for a little while. But if you want to show your video, on the bottom of the Zoom window, there's a share screen.
Yeah, actually, I can show. Let's see if I open here. So
She also posted it to the chat window if you want to just click on that and watch it yourself. And since we're talking about the chat window, I posted a link there because as someone says, well, without LiDAR, you're blind. Well, here's an example of a roboMagellan robot that has a GPS and a compass and sonar on it. And basically he says, go to this waypoint. If there's anything in the way, avoid it. And when he gets close to the target, he says, if you see something, run into it. And that's his whole strategy. and he's able to get it to complete the entire course doing that. So you can go back and look at that at some time.
So I hope you can see my screen. So this is, I have some areas that I don't care, some different areas, and the same algorithm needs to work for all the stops. So you can see that I developed this in MATLAB, but it's define what I want. So they building the area for me, and they told me where should to begin, where should to finish. Here is kind of lag, and I have a different positions for the path planning. So the red is kind of move, the black is kind of move but without cut, if we're thinking about the grass or something like this. And we can also move like around the things. So we can have a different paths. I can also define which point I want to begin, and they building this for me. So you can see begin here and finish here, or whatever they're doing. So I have a kind of more strange path with the same algorithm that and always define with the flag or something like this. So this is one other. You can see that here I have 3 different areas, and I need to define this zigzag plan in all the 3 areas. Something like
Elsa, that pop-up window is all gray. Does everybody else see gray, or is that just me?
I don't see anything.
I
Oh.
see it too. That is gray square.
Okay, you cannot see the colors. Oh, so bad. But maybe you can see my video and you can understand. And I can send this for you if you want. So, yeah. But yes, it's a building by equations, and I test this with a lot of areas, and some is very strange areas, not realistic areas, but I want to see my performance of my algorithm. And always is building in the zigzag, and you can define the angle, you can define where you begin, where you finish. If you want to move the tool, for example, is a little more like Matthew described, if you want the tool up in the corner or whatever you want. So it's very, I think it's very, it's not a rich algorithm, you know, it's kind of, yeah. So
Wow.
my job is kind of this kind of things, you know, math and software. I can tell that I'm a little blind in hardware. When I need hardware, I call Jeff all the time.
We all called Jeff.
So, yeah.
I was just looking at your planning algorithm work there for the shapes. You've got like 2 shapes inside of a bigger shape, and that's amazing.
Yeah, and maybe I can, I don't know how this is work, because it's kind of processing, very high processing, but let's see what I can do it. Actually, I think I stopped my MATLAB. But yes, I can send maybe the link for you, one very, not a realistic shape that you can see that the algorithm is working very good. And you can also add the n obstacles that the algorithm will work.
Okay. And then, so if you pull your lawnmower up to the field or tractor up to the field, does it take whatever position?
Yeah.
That
First, what I need is the space, of course, the closed space, the closed area. I need to have this. And I need to have the border for the area and border of the obstacles. This is what I need. And maybe this is nice because I converted this everything. But if you give me in GPS points, in UTM points or whatever, I convert this in my equations, and I recalculate this, and when I send out in the vector, sorry, in matrix, more correct, and I send like the coordinates and the position of the two of the machine. So, and we test this in a little bit with our Davis with a square, actually rectangle area, and this is sounds nice.
Excellent. Good
The
job.
good things is you not need to enter the points all the time. Of course, you have this advantage that you need to pre-calculate this before.
But once
it's
you
not
have
dynamic.
the border of the shape, then you're done. You can just
Yeah.
load the path up.
Yeah, but I mean, this algorithm is not dynamic. So if, for example, we need to have like a lag, but certainly if you not define the lag, the machine go drowning, you know. So it's not like they see the lag and trying to avoid. But maybe we can. I need to. I didn't have time to to better perform with this, but maybe it's nice if you forget to give me one lag. It's nice that the algorithm dynamic can prevent this or something like that. So I need to put a little intelligent in this. In this limit is not intelligent. It's actually a little stupid.
That's excellent. Fascinating. It's a hard field. Planning and controls are two hard fields in robot land. AI, but yeah. It's excellent. So you put those into ROS packages then, or does a different pipeline?
Yeah, what I did is we calculate this in the outside, like I said, and I get this matrix and send this to the ROS. And yeah, but the idea is maybe building this and convert this in C and make the all calculations. Yeah, it's kind of, I have many equations behind because it's not a square, you know, it's something. So this is a little complicated when you begin to be a little corns and something with many rounds, and yeah, the corn is not totally 90 degrees. You have a kind of, 23 degrees or something like this. This begin to be a little funny to do. Yeah.
Yeah, I saw a paper from Carnegie Mellon and John Deere about their algorithm through the orchard. And I think the last paper I saw, they got a 17% improvement for just how many miles it took to get through. But I don't know, how do you score a planner?
How I score a planner?
Yeah, like, how do you know it's a good one or a bad one? Or, I mean, if it works, I guess you're saying if it works, it's good, ship it.
What I see is kind of, I need to go in every point in the area. And of course, you need to define also the pitch between one path and the other path. And so I need to cover all the area, and the lines not need to cross, of course. And so the good plan is when you go in passing all once. So this is, for me, is what I define good plan.
Okay, so you don't have to backtrack and go over a little area.
No, but sometimes, of course, you need to do this because it's so complicated path. So you need to do this, but the definition is this: so go once and go in this algorithm you can define where you want to begin. So sometimes you get the wrong points. So, but the machine tell you that this is the best points that I can cover. So I try to run here the more complicated one and maybe show only the picture that you can see what I mean. So, but again, it's maybe this need to be work a little more. You know, I need to put my fingers in this a little more. No time.
No time.
No.
You need a little robot like Sohin so you can test out your planner
Yeah, exactly.
or simulator. Or a big robot. Just get Darvis out there, drive it around.
Yeah, we test with Davis.
Davis.
Kind
Yeah.
of okay. Yeah.
Fascinating, Elza. That's excellent. We're not to the point where we're trying to plan out fields yet, but it sounds like someone will be next week, maybe be in a month.
Okay.
Not next week for sure, but next week I'm hoping to have some progress. Hopefully, currently I'm not able to run RViz on NVIDIA, so I'm stuck on there. But yeah, I haven't gotten to that error. I'm sure there's some. I've looked at some answers on raw sensors, so I'm gonna go back to the lab and test them so I can get it working. I want to get the RViz working so that I can see how my localization is working. So that's the plan for this week.
So your robot computer is your main development computer?
I'm trying to develop on the NVIDIA itself rather than using a computer. I'm just trying to build everything. Like I'm downloading everything on the NVIDIA and then building everything on there. I just have connected it to a screen. So it's pretty fast. Like it's not like a Raspberry Pi for sure.
Yeah.
So I'm trying to test it.
The Jetson Easy, did that come with everything pre-installed or was it missing? Was it just like the bare bones?
So I bought the TX1. I don't know about the Easy one that you mentioned right now. So
there's a GitHub account where they put together a package to go on the Jetson.
Oh wow, I didn't know that.
There's like a whole ROS development on the TX1.
I wish I knew about it earlier.
I think it's called Jetson Easy.
Yeah, I just found it. I shared the link. No, I used Jetson Hacks links to set it up. So I installed the Ubuntu on it using NVIDIA's Jetson software. I don't know what they call it. I mean, I know what they call it. I just forgot. Jetpack. Jetpack is what I used to install Ubuntu on it, and then it has Ubuntu and all the neural network stuff on it now. So I'm like, in the future, I'm planning not to scrap anything now. I'm just gonna keep developing on top of it. That's my plan for this robot. Like, I've started building it up, and now I'm gonna hook up Kyler's arm on top of it, and I'm gonna hook up the camera on it, and I'm trying to see, like, I'm trying to do everything. It's gonna look like a weird animal, like, you know, that has a hand on its back and other things. Trying to just play around, but yeah, that's what I used. I used Jetpack. I used Jetson Hacks link to install ROS on it, but I've had some trouble installing ROS completely on it with that link. Oh well. Tech demo.
So this is the complicated one. This pass, of course, not exist. But you can see they are pretty good. And sometimes I need to the blue ones line. I don't know if you can see the colors, but sometimes I need to cross the line because I don't have no other option. But my intention here is to test the algorithm, you know, for see if in the this path or this area, what the algorithm is doing. And you can see that we have two borders. One is points, and this point is kind of space that I have for turn the machine. So the area I need to do is inside this path planning. It's not nice. I cross the area between the points and the blue one. But it's not nice, so I can do it. But I never can get out from the blue one. Let's see this way. So you can tell, okay, this is not real, this area. Yes, I agree with you, is only really for test how far my algorithm going to be. So this is one example. So
Wow, excellent. Didn't fail.
fail? No,
Yeah,
no.
the planner made it all the way around.
Yes, yes, yes. So, and I have other areas that, but it's the same.
What kind of computer are you using to solve all these matrices? I bet it's a bit compute heavy.
Yeah, it's actually, when you talk, my processor is working. So for this path planning, I need to have a patient. This is why I'm not, it's like I begin to processing and you talk.
Mm-hmm.
So maybe 10 minutes, 7 minutes for that area. So yes, we need to have because they make the calculations and after they build in the path. So what is take my processing out is the calculations.
Right, but in your, I mean, the way your algorithm works, the robot's not going to start moving before it has all the paths. So that's a plus. I think that's not a problem for you, because if it takes like 15 minutes, that's fine. The robot will just be standing there, and once it has the path, it's just going to execute.
Do it. What we can do is kind of have a like let's see, web page, and you pre-calculate this, and after you pre-calculate, you send the entire vector, entire matrix to the machine. So one is calculate, this is done. This is what I tell is static. So yeah, for you, I need to have another area. So you need to calculate again. So
it's interesting. I'm thinking about applications here, and I mean, it would be fun. In the future, we'll have everything on the cloud. Like the cloud will be calculating the paths on the fly, while the robot will just keep asking for paths and just start executing. So
one very good application I can see is lower for golf, golf area. So you have many places, and this places is not square, it's something else, and you can move also one machine to different areas. So, and you can have for me, legs or trees are the same, is obstacle. So, you can define your obstacle and something like that. So, yeah. Okay.
Really cool.
Yeah, so one of the things that was brought up at the AgBot Challenge is in agriculture, it's like most of the path planning, you'll have that line where you want your robot to drive on, but in ag, sometimes you want to drive over the rows. And so if you put like a boundary or an obstacle of plants where you don't want your vehicle to cross, how do you drive over the top of it? Like, how do you stack all those layers where I don't want to drive across the rows, but I want to drive over the top of them?
Yeah, if you define in this algorithm, if you define that is an obstacle, you're not cross. They not accept your cross.
Yeah.
No exceptions.
Yeah.
So again, maybe we can have a little flexibility here, but the algorithm way to do is kind of not do it. You not cross the obstacles. No.
So it
So-
wouldn't, it's right now, I don't think it's possible to put the plant row as an obstacle if you're going to drive over the top of it in Ross.
Okay, yeah, okay. Yeah,
So we may need, in the future, as we develop, that may be a concept, you know, that's specific to agriculture where you're driving over an obstacle row.
yeah. Or
It's
maybe
like-
more flexibility that you can do it or just, yeah, you know,
I
kind of
think,
condition.
oops, sorry. I think a better solution or a better suggestion would be to not have crops as obstacles and have obstacles as obstacles and define another thing such
Okay.
as crops, like a new class, you know. That would be a better way to approach that, I think. In that case, there would be clear definitions, because what if sometime we think of an obstacle as a crop, then it's gonna try to run over it and it's gonna mess up the machine. So
Yeah. I wonder if it'd be good to contact the guys that are, people that are working on the navigation stack for ROS 2, to kind of throw that out there, that it would be nice to have some, you know, name that where you don't cross the row, but you can go over the top of it.
Okay.
I was hoping Kyler was going to be on tonight because I wanted to ask him, you know, we discussed earlier our previous meeting today, and I was saying that it's nice to have a precision GPS to drive straight lines across the field, but now once the crops come up and you go back to spray the plants, I wanted to ask Kyler, does he trust his GPS to do that, or is he willing to take out entire rows at a time? It just seems like, you know, once the plants come up, if you're off by a little bit, your wheel's going to run over the one row of crop all the way down. And it just seems like, you know, if he's, because I don't think he has a camera or anything to see where his plants are. So I'm curious if he's attempted to go back and do anything else after his corn comes up. But he's not on tonight, so I can't ask him, I guess.
Yeah. I don't have a lot of experience on those, but the tractors I've been on, it will drive the same row. I mean, if you have a recorded path and you want it to go down that same line, it will drive that same line. It's very impressive. And that's just using the onboard guidance system. On the harvesters, they have those little like curb finders on the heads. Once the plants get tall. Have you seen those? The little adjustments? There's like little feelers on the heads that they're going through, adjusting those.
Are you talking about on a corn picker, or are you talking about earlier than that on corn picker? Yeah, I've seen those, but I don't know. See, when the plant's is 6 inches tall and you go through to spray it, I just wonder if there's any way to identify that. It seems like that would be pretty hard on your plants if you had something that was mechanically finding the row. But you could use a camera or a laser scanner or a sonar or something to try to track the row. So as I say, I wanted to ask Kyler if he's attempted that, gone back with GPS and said drive exactly where you went before, because I'm just curious how close that comes out.
It'll be within 2 centimeters.
Well, we'll see if it is. That was my question.
Yeah. It's funny. I was working with a farmer down in California, and they went out and he had a new tractor and was testing the auto guidance system. He went up and down, back and down these rows, and then got out of the tractor and stuck a tape measure to each of the mounds. And he wanted to see that he was within the distance that the dealer said. You know, he wanted sub-inch, and he was. Well, we went out with the dealer, but it made it. It's unbelievable.
So I'm wondering if you come back 3 months later and run the same path, is it going to be the same, or is it going to be off by some amount?
Well,
doing everything within half an hour, that's one thing, but you come back later to try it again.
sure.
I'm just curious how it's going to work out.
Okay, so like you can, if you neglect the tectonic plate shifting you will be in the same spot. That's the whole purpose of the RTK GPS. You have an external reference, a frame of reference, and then that gets you your specific point. It's 2 centimeters. I mean, depends on your GPS, obviously, but if you get the high cost GPS like Kyler's running, amazing. What are you running on your tractor? Like the Novotel span, or?
Yeah, that's the one in Denmark. That's what we have. So it was like an $18,000 GPS. And the other ones we went with the Swift Pixie Multi.
Yeah,
And
so on that,
I realize that's the intention, but if you come back 3 months later and check it, is it really on that particular day? Is it going to be accurate? And
I can't. Have you ever tested that?
No, I haven't. So that's why I wanted to ask Kyler how it worked on his fields. So.
Okay. Yeah. Well, I've mapped vineyards. So vineyard rows, you have a 9 to 11 foot vineyard rows, some smaller, but you'll go map that in the spring, and then you may come back the next spring to do a demo, pull up the same map, and you can drive those rows. You have to get your robot through those rows. So you're dodging obstacles and fence posts all the time. I haven't worked in the open ground. But if you survey in your base station, if you have a local base station and you survey that in, your map will be accurate the next time you come out. That's the point. It's a fun test. It's worth doing. I've also got completely off and had to move the base station and made tons of mistakes on the GPS. So there's some trial and error, but it's worth doing. I'll give you an example of one of the errors I made. I put the base station, so I had this platform that could elevate up 30 feet. So you can run your robots and see down into the field. Well, we put the base station on top of the roof of this elevated platform and did mapping, but there was a difference between when the platform was down and when the platform was up. It was like 6 inches, it shifts. And wherever your base station is, if your base station shifts 6 inches, your robot shifts 6 inches in the real world. So there's some fun dynamics that can happen. Probably would suggest putting your base station on a fixed position, or if you want to have fun.
So far, we've used the DOT correction data, so we didn't have our own base station. So there could be another issue there about how accurate the data is going to be. So it might be worth finding a post out here somewhere that I can put a GPS on and sample it one day and then come back later and check it again to see what it's doing. I just can't put it on top of there's a no parking sign in the back. I can't put it on top of that because if you touch a sign, it'll shock you because we have these real big power lines up above, and just touching something that's there will zap you enough that you don't do it again. But I should be able to find somewhere that I could mark and then come back later and check it.
It's a fun game. It's hard. There any other topics or comments to make for tonight's meeting?
Wow.
Go ahead.
Colin?
Well, I just wanted to say, following Jeff's remarks last time about the virtual machine, virtual box, I managed to install a virtual box on my machine and Ubuntu on top of it and ROS, and so I'm going through the course of it. Also, I went through the 5-day that 5-day course for us. I'm finding it interesting. I think that's all. It's not progress, but update.
Okay. I'm glad you're going through that 5-day course. It's really useful, helpful. I went through it this weekend. I listened to the videos this weekend again and picked up some more.
Yeah, it's very useful. You pick very critical, important aspects of us from there.
Yep. It's great to hear. Matt?
Sorry, I'm new to using this program, so I have to figure out where all the buttons are. Yeah, I just put a link to my webpage if anybody wants to check that out for my robot lawnmower. And I pretty much have all the mistakes that I've made written on there, so everybody can see it and laugh and say, okay, I don't want to make that mistake. So, and then I've got where I am so far. So it's not very far. So, yeah, that's that.
Awesome. Thanks for posting it. Thanks for being here. We'll check it out. I think the lawnmower is a fun platform, small, but still can do some work. Thanks for your presentation, Elza. That's really fascinating on the planner. Some good work there.
Yeah, welcome, Matt.
Next week,
Yes.
yeah, next week I will show you pictures. We are starting cutting weeds today. So I'm trying to take some pictures, but it won't be robots.
Not yet. All right. Thanks for your presentation, Sohin. I liked your little robot car. It'd be fun to get it out there, get that machine running.
I hope so too. Yeah, thank you.
Great. Thanks, everyone. Sam, hope you're feeling better. And we will see you next week, if not online before. Have a great week, guys.
Yeah.
Yeah, thank you. Bye-bye.
Bye-bye.